So as I mentioned, even though the previous page had all base 10s, which is the common log, which is actually a little bit easier, if you memorize one rule, and if you remember that log base b of a equals x is equal to log of a divided by log of b, it will work for any number, whether it's 10, 2, or a million, it's going to work out. So if we rewrite these in log form as it asks, and then solve for x, here's what it'll look like. Log, this is your base. It's the base of your power, so it's going to be on the bottom here, of 32 equals x. The goal here is to get a variable by itself so we can solve for it. So then the consistent rule will be log 32 divided by log 2, and hit enter. One thing to be aware of when you type this in your calculator, you have to make sure that you close the parentheses. Students in class were not closing this parenthesis, and it totally messes up the answer. What you end up with here is x equals 5. That means 2 to the 5th power equals 32, which makes sense because 2 times 2 times 2 times 2 times 2 is in fact 32, so we're good. For part B, log base b base bottom base is 3, and then that gigantic number equals x. So in your calculator, you can type log of the giant number. Make sure you close the parentheses and divide by log 3. When you do that, you should get 16. That means 3 to the 16th power is that gigantic number. That would be 43,046,721. If you want to pause the video and try these next two, now would be a good time. This one, log b base bottom, the base of the exponent is 4, so it's going to be 4 of 164 is equal to x. Typing that in a calculator would be log of 164 divided by log 4. And you should get 3.68. I believe some of the rounding here is goofy. I wrote it down, but I think the rounding may be off. My apologies. The rounding may be off, so trust your math, what comes out in the calculator. And then this one, make sure you notice that's a decimal, so it should be 0.5. So we're going to go log b base bottom is 0.5 of 11 equals x. So we're going to type log 11 divided by log of 0.5. That's our x value. When you type that in, you should get negative 3.46. I'll show you how you type these into a calculator just to be super clear. We'll do part A first, log 32 divided by log 2. So you'll type in log 32 and then make sure you close that parentheses. Divided by log 2, close that, and we get 5. Log 32 divided by log 2 is 5, and that's what we got right here. All right, and then this one we're working backwards. We're writing an exponential form to solve for x. So this is our b base bottom. It's going to become the base of our power. This becomes the exponent equals x. 5 squared is 25. This one is so easy it's difficult. There is nothing written right here. That's what I was talking about, where we assume it's a 10. So this is actually log base 10 of x equals 4, if you want to rewrite it. So we have 10 to the 4th power equals x. 10 to the 4th power means 10 times 10 times 10 times 10, which is 1 followed by 4 zeros, 10,000. And then we have these last two. Log base 10 of x equals negative 3. So it would be 10 to the negative 3rd equals x. And when you put that into your calculator, 10 to the power of -3, we get, here's how you do the caret, 10 to the power of -3.001. It moves the decimal place 2 spots over. This one's weird because it has that half power. People tend to panic, but it starts out the same way. You could type this into your calculator, 16 to the 0.5 power, but remember that's the same as the square root of 16 from the previous unit. So we know that x is 4. All right, this last problem is a little bit more in depth just because it's a word problem. Says the population of Logville is 1,500 and it's growing at 5%. How long will it take it to double? So we have to figure out y equals ab to the power of x. A is our initial, which is 1,500. B is our growth rate, which is 5% in addition to our 100%, which is 1.05. Then we have to figure out x and y, the two variables. The two things being measured here are population and then time, because they want to know how long. Remember, this one is going to be time almost always. They want to know how long, so this is what we don't know. And then last is y, which is the population. They want it doubled, which means we're looking at 3,000 people. So if we fill in what we know into this formula, we got 3,000 equals 1,500 times b to the power of, b we know is 1.05 to the power of x, which we don't know. Divide by 1,500, divide by 1,500, chunga chunga. 2 is equal to 1.05 to the power of x. We know how to deal with this now because we have exponent, mystery exponent. We can use logs. So we rewrite as log base 1.05 of 2 equals x. And in our calculator, what we're going to type is log 2 divided by log 1.05, which equals 14.21. So it would be about 14 years, a little over 14 years for the population to double.